Okay, trig or advanced algebra, whatever you want to call yourself. This week we are finally going to learn about radians. What's today's date? 26 May 2020. So that weird thing that you have seen on your calculator before, it says RAD. That stands for radians. Today you're going to learn what they are, what they mean. It's confusing. It's kind of like radicals. Radicals don't really make that much sense. Radians won't make that much sense either, but I'll try the best that I can. Yeah. So you know how in geometry and then everything you've done in trig up to this point, we've always said make sure your calculator is in degree mode. Make sure it's in degree mode. So there is a relationship between degrees and radians. And matter of fact, the word radian and the word radius look the same, and it's not a coincidence. They kind of mean the same thing. So they go together for sure. So this circle right here has a radius of exactly 1 inch. You can get your ruler out and measure it if you want to. By the way, it took me a long time to figure out how to make that graphing program do that, but check that out. Exactly 1 inch. So you know from geometry the circumference of the circle, circumference equals 2 times pi times the radius. Yeah? And in this case, let me go approximate. We know that pi is about 3.14, and we know the radius is 1, so the circumference is about 6.28 inches. Yeah. This line segment down here that you are looking at is 6.28 inches. That also took me a long time to figure out how to do. Yeah. So 6 inches there and a little bit past 6. Okay. This is 6.28 inches long. Yeah. See? Well, pretty close. If I bend it into a circle, and then it should fit perfectly over that circle. So that's the relationships between radius, radians, and circumference. They all go together. Yeah. Next page. So what are radians in general? And what do we use them for? Why do they even exist? Interesting question. So, by the way, what you are looking at is a unit circle with a radius of 1 inch, by the way. But each of these points that I have put on this circle, which took me a long time, by the way, is exactly 1 radius long, or 1 inch long, 1 radian long. So a radian refers to the length of the arc. So usually angles are measured in degrees. So this is like real close to 60 degrees. I think it's 57 degrees or something like that. So angles are measured in degrees. And let me find my highlighter. Arcs are usually measured in radians. So what is the length of this piece of the circle? That piece of the circle is called an arc. So arcs are usually measured in radians. And angles are usually measured in degrees. However, they are interchangeable. Like, I could say this angle is 57 degrees, or I could say it's 1 radian. Your brain kind of can conceptualize what degrees are, because you've seen it your whole life, basically. But radians, it doesn't make too much sense. So, radians are, I'm going to highlight it in yellow, like so. Why do we use them? Let's say this is our solar system. That is the Earth. That is Mars. Let's say that Earth and Mars rotate on the same axis and in the same plane. They don't, of course, but let's say they do. It wouldn't make sense to say, well, the distance from Earth to Mars is 57 degrees. That makes no sense. But you could say the distance from Earth to Mars is 50,000 miles. You're talking about the length of this arc, and that's what radians are. 50,000 miles would be the approximate answer. Something with a pi in it would be the exact answer. Why pi? Because why pi? Why pi? Oh, because pi is exact. 3.14 is approximate. So that's why we use them. Also, by the way, almost all college textbooks, college math, deals with radians and not degrees. Why? Because, like I said, it makes more sense to talk about distance in an actual number. Radian is an actual number rather than degrees. Degrees are kind of like relative. Okay, and next part. These are all equivalent. 30 degrees is equal to this many radians, and if I were to replace that pi with a 3.14 and divide by 6, that's what you get. So this is exact, this is approximate. It's kind of like, it's very similar to radians. Like if I gave, or not radians, radicals. If I gave you something like this, right, and I said simplify it, you would write 4 radical 2. Yeah, that's the exact answer. Does that mean anything to me? No. Does it mean anything to you? No. But if you were to tell me the square root of 32 and get an actual approximate answer, square root of 30, mother dookie, square root of 32, 5.7. That actually means something. I can picture in my head what 5.7 inches looks like, what 5.7 feet looks like, 5.7 miles. I have no idea what 4 radical 2 miles looks like. Right? So it makes, the approximate answer should make sense to your brain. The exact answer often in math will not make sense. So, similar, very similar. You have a exact answer, approximate answer. Exact answer, approximate answer. Okay. Let me just show you real quick that this divided by 6 does equal 0.52, or approximately 0.52. This calculator happens to have a pi button. 0.52. Yeah. If your calculator does not have a pi button, go ahead and use 3.14, and you get a decent answer. The first answer is better than the second answer. Just saying. Because pi is exact, 3.14 is not exact. Okay? So let's go back to this page, and let's go all the way back to circumference again. Talk about that for a minute. We know circumference is equal to 2 times pi times r, and that's the distance around the circle. R is 1, so you could say circumference is 2 pi. Yeah? Because the radius is 1. Okay? If I asked you what is the distance around this circle in degrees, you would say 360 degrees. Yeah? So 2 pi is equal to 360 degrees. Should make sense. Yeah? And if I cut that in half, I get 1 pi. If I cut that in half, I get 180 degrees. That's going to be very important later. Okay? Also, if you think about it like this, what number can you replace pi with that you know? 3.14, yeah? But that's approximate. Yeah? So 3.14 radians. Think of it this side as radians. Yeah? So 3.14 radians, which is just a generic term. It could be 3.14 inches, 3.14 feet. It depends on the length of the radius. Anyways, pi is equal to 180. 3.14 is equal to 180. Super important. Super important. Make sure you write that down. Because on the next part, I'm going to explain. So, we know that distance all the way around is 360 degrees. We also know that it's 2 times pi, or 6.28. Okay? So the distance from here to here is 1 radian. 1 radian. From here to here is 2. Then that's 3. Notice 3 doesn't quite make it to the 180 degree mark. The difference is, guess what? 0.14. And that's 4 radians, 5 radians, 6 radians. This little bit of leftover is 0.28. By the way, I know radians doesn't make sense because it's not a measurement that you're used to. You could replace that word with the word inches because I made sure that this is 1 inch. But if we didn't know how long the radius is, then you would use the word radian. It's kind of like a generic measurement term. So, believe it or not, this from here to here is 1 inch. From here to here is 1 inch. If we were to cut this piece out, straighten it out, it would be 1 inch on a ruler. Yeah? Oops, that's upside down. From here to here is 2 inches, here to here is 3 inches, 4 inches, 5 inches, 6 inches, 6.28 inches. Does that make sense? Hopefully that makes sense. So if I were to ask you, where's 0.52? You know that that's one. Think of it like inches. This is 1 inch, so half an inch would be about right there, which is about where 30 degrees is. So if I were to draw a 30-degree angle, I know right there is 45, so I'm going to go right there. So there's a 30-degree angle. Yeah? Well, if I ask you how long this is, you would say it is 0.52 inches, or 0.52 radians long. Or a better answer than 0.52, pi over 6. And I'm going to show you how to get this answer in a little bit. Yeah? That's way off, by the way. That should be more down here. Whoops. Oh well. I should have used a protractor. 200 degrees, you know, is somewhere, let's see, from here to here is 180, so 200 is about right there. Yeah? Let me draw that angle. So this angle is 200 degrees. How long is the length of the arc? Remember, that's what radian means. The length of the arc. That's 1 inch, 2 inch, 3 inches, not quite 4, so about 3.5 inches. So 3.5 inches. That makes sense to your brain. Should make perfect sense to your brain. That, however, does not, and that's what I'm going to teach you in the next part of the lesson, and the next video. So hopefully you understand a little bit about what radians are. Radians are how long is the length of the arc. Degrees are for angles. Yeah? They are interchangeable. It just sounds weird to say, oh, that angle is pi over 6 radians wide or whatever. It sounds weird, so that's why we use degrees, or we're used to degrees. Next video, I show you how to convert, and that's what the